This methodical represents a degree 7 polynomial map in 3 dimensions. While it appears continuous, it possesses a structural asymmetry that allows it to be locally flat while remaining globally non-invertible. This is the leavened Alpöge counterexample. It maintains a constant Jacobian determinant of -2, a value that successfully hides a 3-to-1 global topological branch sheet within its coordinates. This table shows a sharp boundary at 3 dimensions. In lower ranks, rigid algebraic curves and linear boundaries enforce global injectivity. But at n equals 3, the Alpöge map proves that these local constraints no longer guarantee a 1-to-1 mapping. This structural failure triggers a domino effect across several related problems. Because the map is purely real, it provides an immediate counterexample to the real Jacobian conjecture and begins to destabilize the algebraic protections of higher-order Weyl algebras. The BKK sequence linearizes the Alpöge map into 24 variables, preserving the 3-to-1 collision. Node 2's symplectic lift pairs them with dual coordinates via the inverse Jacobian, creating 48 dimensions. Finally, quantization replaces coordinates with non-commuting generators of the 24th Weyl algebra. On the left, the operators maintain their required algebraic structure, but on the right, the underlying spatial folding makes it impossible to uniquely reconstruct the base fields. This proves the existence of a valid endomorphism that is not an automorphism. This means that in these higher-rank algebras, a smooth path in quantum space can be generated by structurally distinct algebraic operators, breaking the assumption of operator invertibility. We can track this collapse further using an Adelic liftoff. This process embeds the non-injective map into the ring of adeles, viewing the 3-to-1 folding as a product of local and global data structures. This liftoff creates a 3-dimensional Galois representation, where primes split into 3 cycle states. Split primes yield an identity state. Transposition primes introduce a negative eigenvalue, creating a phase rotation. Inert primes map to cube roots of unity, canceling to 0. These Satake parameters determine how individual prime components are distributed across the 3 overlapping data channels of the global representation. Using these parameters, the Shintani-Castleman-Shalika formula calculates local wave function amplitudes. The resulting Whittaker function scales based on the prime cycle. For the split state, where all parameters are 1, it mirrors standard dimensional growth, representing a locally flat, parallel data channel. Take a moment to consider the inert state. If the parameters are complex roots of unity, what happens to the amplitude if the coordinate partition doesn't align with a modulus of 3? Because the phases perfectly cancel out, the amplitude vanishes. The data stream effectively screens these dimensions unless the coordinates conform to a specific teriodic lattice. However, at the prime p equals 2, the constant Jacobian determinant of -2 forces a breakdown of this flatness, creating a locus of wild ramification. Calculating the index of the parahoric congruence subgroup at this prime yields a core space volume of exactly 1/7. Within the framework of Logos field theory, this value defines a discrete mass gap. 1/7 of the local operator space is consumed by the nonlinear coupling of the sheets, pinning the branch locus to a sharp adelic fraction. Finally, we map these local Whittaker functions into a macroscopic Feynman path integral. Here, they act as discrete phase modulation weights within the action functional. These weights, denoted as WP, apply the derived phase rotations and erasures to the particle's path across the adeles. This creates a filtering effect. Transposition primes trigger sign-flipping frictions that suppress nonlinear curves, while inert primes cancel out smooth motion entirely, leaving only discrete hopping networks. The smooth trajectories of classical physics emerge from this process as a constructive residue. As the non-abelian adelic filter erases the most erratic path histories through destructive interference, only the straightened constructive paths remain visible at a macroscopic scale.